Hi guys, so today we're going to look at our quiz review over vectors. So this is going to cover everything we've done with vectors so far. Keep in mind you are going to want a calculator and you need to make sure the mode is in degrees. Make sure your mode is in degrees. All right, so we're going to start by finding component form and magnitude. So remember component form, that is when you have the pointy brackets and you have basically the horizontal length and the vertical length. Also remember that those components can be negative. So looking at the first one, because we're starting at 0, 0 and ending where the arrow is, our x would be negative. Our y, we're going up a distance of 3. So that's my component form. All right, I'll go ahead and find component form on the next one, and then we'll find magnitude as well. So component form on this one, the x will be positive. I'm going right, 1, 2, 3, 4, 5, 6. And my y will be negative because I'm starting at negative 4, 4, and I'm ending at 2, 1. So I'm going down 1, 2, 3. All right, once we know our components, then we can find magnitude. Remember, magnitude is just Pythagorean theorem. So if this distance is 1 and this distance is 3, it'll be the square root of negative 1 squared plus 3 squared. Keep in mind, if you have negatives, you need to be careful with your parentheses. The squared should be outside the parentheses. The negative number is inside the parentheses. You should never get negatives when you square this. There'll never be a negative under the square root. So this is going to simplify to the square root of 10. All right, on the next one, we would do for magnitude, 6 squared plus negative 3 in parentheses with the squared outside it. So that's going to be 36 plus 9, which is the square root of 45, which should simplify to 3 root 5. All right, so now let's find component form given the initial and the terminal point. Now, if you prefer to do this with a picture, like we did the last one, just draw the picture. Okay, I'll go to negative 2, 6. And then I'll end at 5, negative 4. Then from there, I can see pretty easily what's going to be positive and negative. The x would be positive. I went over a distance of 7. The y would be negative, which is a distance of 10. Now again, if you want to solve this without the picture, remember we do the terminal minus the initial, the end minus the beginning, because that helps us see the direction. So you could do 5 minus negative 2 and negative 4 minus 6. That's how we can do it algebraically. All right, same idea in the next one. Either draw the picture or terminal minus initial. So for the x's, negative 2 minus 6. For the y's, 5 minus negative 1. Again, if you want to check your answer with a picture, or if you just want to draw it out, you are welcome to do that. That might make it a little bit easier. So negative 2 minus 6 is going to be negative 8. 5 minus negative 1 would be 6. Again, if you're not sure, you just want to check, let's draw the picture. 1, 2, 3, 4, 5, 6. Negative 1 is where we start. We end at negative 2, 5. So that can help us see our direction here. Okay, I'm going to the left, so the x is negative. That distance is 8. And then up and down, I'm going up 6. All right, now let's find magnitude and direction. Okay, so from component form, so from your x and y, remember magnitude, we're doing Pythagorean theorem. Okay, so the magnitude of this vector would be the square root of negative 2 in parentheses with the squared outside it, plus 5 squared. And that is going to be the square root of 29. All right, for angle, the direction, we're going to use tan inverse. Tan inverse, and it's y divided by x. Tan inverse y divided by x. Now with these, you need to be careful. Probably the most common mistake here is forgetting. If this is in quadrant 2 or 3, if the x is negative, quadrant 2 or 3 and the x is negative, we need to add 180 to whatever we get. So plug that into your calculator, add 180, and you'll get 111.8 degrees. So don't forget that plus 180 if the x is negative or if it's in quadrant 2 or 3. Again, if you draw the picture, that can kind of help you see. If I go left 2 and up 5, okay, that angle, it doesn't look like it's a negative angle. It looks like it's about 110 degrees. It makes sense. My answer is reasonable. All right, for the next one, again, magnitude, we're going to do Pythagorean theorem. So 4 squared plus negative 5 squared, and we'll square root it. Again, make sure that negative 5 is in parentheses and the squared is outside it. So that is going to be the square root of 41. All right, for my angle, tan inverse y divided by x. This time we do not need to add 180 because, again, this is going to fall in quadrant 4. If I go over 4 and down 5, I would be in quadrant 4. So when I plug this into a calculator, then I'm going to get negative 51.3 degrees. And again, that makes sense based off my picture. That takes us into the fourth quadrant. Now we're going to go the opposite way. We're going to find the component form if we know the magnitude and direction. So component form, remember, we're looking for an x and a y. For the x, we'll use cosine. For the y, we'll use sine. So the x is going to be 5 cosine 110. The y is going to be 5 sine 110. So this one, we'll go ahead and plug it into a calculator. 5 cosine 110 would be negative 1.71. And then 5 sine 110 is going to give me 4.7. All right, let's try our next one. Again, same formulas here. These ones will give you kind of some square root numbers because 30 is a unit circle value. If you really want the practice, you also could do this one without the calculator. So 23 cosine 30 is the x. 23 sine 30 is the y. So 23 cosine 30 is going to be 23 root 3 over 2. And then 23 sine 30 is going to be 23 over 2. That's your x and your y component. So remember, cosine's x, sine is y. For an angle, we do tan inverse y over x. And those are really the only formulas you need to know kind of for this whole quiz. All right, let's find resultant vectors. So performing these operations. So remember, if we do these algebraically, keep your x's together, keep your y's together. So u minus v minus w. So what you'll do for your x's, you'll do u minus v minus w. Then for the y's, you'll do u minus v minus w. However you want to write it out, whatever is easiest for you. Again, just keep the x's together, keep the y's together. So that is going to give me, let's see here, a negative 5 for the x component. And then for the y component, that's going to be 13. Okay, if it helps you to write it out vertically, you can do that as well. So negative 4.7, that's u. I'll go ahead and do minus v. I'll go ahead and just change it. And then I'll do my w. And it's a minus w, so I'll change it to negative. And then if you want to just add vertically, then you can still get negative 4 and 13. That's a little easier to see. But again, keep your x's together, keep your y's together. All right, that next one, negative 3u. So let's go ahead and do negative 3u. That's going to be 12, negative 21. 3v, that's going to be negative 6, negative 24. And then negative 2w, that's going to be negative 8, negative 4. We'll add up all of our y components there. That's going to give us a wrong answer because I made a mistake there. Let's do 3 times negative 3 and get negative 9, not negative 6. 3 times 3 is 9. Now let's add those up, and we'll get negative 5 for the x component. And then I've got negative 21 minus 24 minus 4. Combine all those together. That'll give me a negative 49 for the y component. Again, keep your x's together, keep your y's together, and that will give you your correct values. All right, so now we're going to go into kind of some word problems. So something like this, your other two answers are going to be dependent on the first one. If you see something like this on your quiz and you're not sure how to get that first answer, at least put something there. Because if you don't have anything, then there's no way you can do the next two questions. So even if that first answer is wrong, at least get some answer there so that we can do the other two questions based off that. Okay, so the component form of the resultant, what that means, add these three together. Add all three of them together. So add your x's together. So 7 plus 5 plus negative 1 is 11. 1 plus -3 plus -8 is going to be a -10. Okay, once you have, that's your resultant. So the resultant here, again, it's adding the x's together, adding the y's, adding all three of those vectors together. If you want to look at it up and down, if that makes it easier, let me rewrite it. So again, I get 11 for the x component and -10 for the y component. Okay, we're adding those three together because all three forces are acting. Magnitude and direction. So magnitude, we do Pythagorean theorem, the square root of 11 squared, -10 in parentheses with the squared outside of it. Okay, be careful with that negative. That is going to give me the square root of 221. If you want to leave these as square roots or if you want to write the decimal, either one is okay. The square root's going to be a little bit more exact. Direction, we use tan inverse, and it's y divided by x. So tan inverse of -10 over 11. And then we do not need to add 180 in this case because this is going to be in quadrant 4. The x is positive. If x is positive, we can leave it how it is. This is going to be a -42.3 degree angle. Again, if you drew this out, if I went over 11 and down 10, that looks like it's about a -40 degree angle. Okay, so my answer makes sense here. All right, equilibrium. We want to find the component form of the vector that would be equilibrium. So we're trying to find what is the opposite vector of the one we found in 11. So all we have to do then is take the opposite signs, and we're done. Okay, so it's just the opposite signs. It's the one that goes in the opposite direction. So 11, -10 would go this way. -11, 10 would go that way. So that's the one that would keep it from moving. It goes the exact same magnitude, but in the opposite direction. All right, last thing we're going to do is some word problems. Now, if you remember these, they'll take a lot of work. They have a lot of steps, but it's not any steps we have not already done. So we'll start with the first one. Judah pushes a box with a force of 8 newtons at an angle of 81 degrees. Jordan pushes the same box with 6 newtons of force at an angle of 25 degrees. So we're going to find the resulting magnitude and direction. So the first thing we have to do is we have to get to component form. So let's get Judah's component form. His x component would be 8 cosine 81. The y would be 8 sine 81. So we can go ahead and plug those in. So 8 cosine 81 would be 1.25. 8 sine 81 would be 7.9. Then we'll do Jordan. 6 cosine 25 is his x component. 6 sine 25 is his y component. So he's going to have 5.44 for his x component. He's going to have 2.54 for his y component. Once we know the x and the y, we want to find the resultant vector here. To find the resultant vector, we take the component forms and we add them together. So add your x's together, add your y's together, and then you'll get the resultant. So if I add my x's, 1.25 plus 5.44, that's going to be 6.69. Add my y's together, which is 7.9 plus 2.54, which is going to give me 10.44. So all of that work and we still don't have our answer. Our answer is going to be the magnitude and direction of the resultant vector we just got. So for magnitude, we're going to do Pythagorean theorem. 6.69 squared plus 10.44 squared and square root it. So the same thing we've been doing, kind of some uglier numbers, but that's okay. There's no negatives to worry about at least, which is nice. And we're going to get an ugly decimal, and that's okay. I get 12.4. So that is going to be your resultant magnitude. Now let's find that angle. Okay, so for our angle, remember we do tan inverse. And we do y divided by x. So again, you'll plug that into a calculator. We do not need to add 180 because this is going to be in the first quadrant. Our x is positive. And I get that my angle is 57.3 degrees. So they would be pushing this at a little bit of a different angle if they're both pushing it at those angles. All right, our last one, another word problem. A little bit harder to get the angles, but not terrible. But same concept. We're going to need to find the component forms, add them together, and then find the magnitude and direction. All right, so a plane flies north at 400 miles per hour. So let's go ahead and draw our plane. Okay, there's a wind blowing at an angle of 43 degrees. So I'll draw my wind. So 35 degrees. So we want to find the resulting magnitude and direction. So I'll start by writing the component form of our plane. So that plane, if we want to find the component form, let's think about the magnitude is 400 because that's the speed. The angle, it doesn't tell us, but if it's going north, that angle right there should be 90. So I could do 400 cosine 90 for the x and 400 sine 90 for the y. You may recognize those because those are unit circle values. So you're going to get kind of some nice numbers here. We should get 0 and 400. Now, we technically didn't even need to use the angle to do that. If you think about this picture, over 0 and up 400, that's going to graph that plane where we graphed it. So our answer here, again, it makes sense. Now let's do the wind. We do need to find those components. They're a little bit harder for the wind. The x component would be 35. Cosine 43 degrees. The y component would be 35 sine 43 degrees. You can go ahead and plug those into a calculator. So I'll get an x component of 25.6. 35 sine 43, I'm going to get a y component of 23.7. So those are going to be my x and y components. So again, just like we did in the last problem, we need to find our resultant vector. So our resultant vector is what we get when we add these two together. So we'll take the plane plus the wind. Again, we have to have the component form first. Don't just add the individual pieces, find the component form. All right, so 0 plus 25.6, 400 plus 23.7, that is your resultant vector. Now we take the resultant and we do the same thing we've done so many times already. We find the magnitude using Pythagorean theorem. And we'll have to plug that one in. That's going to give us a little bit of an ugly number as well. But again, there's no negatives at least to worry about here. So I get the resulting magnitude to be 424.47 miles per hour. All right, and then we'll go ahead and find our angle. So we're going to do tan inverse y divided by x. Whoops. Plug that into a calculator. We do not need to add 180 because we're in the first quadrant. Our x value is positive. So whatever answer we get from plugging it in is going to be the correct answer. And when I plug that in, I'm going to get an angle of 86.5 degrees. All right, so that is it for vectors. A lot of the same stuff kind of over and over again, okay? Finding your components, finding magnitude, finding direction. You're seeing a lot of the same things repeated. Just remember, in order to add them on the word problem, you do have to get the component form first.